Okay, going back to page 637 because we had skipped 2 questions that you can now do. During number 8, during a reaction, 2 deuterons, H2, combine to form a helium isotope, He3. What other thing is produced? So 2H1 plus 2H, and it says it's forming a helium, which is helium-3. So what else is produced? Well, on the top it has to be 4, so that needs to be a 1. On the bottom a 0, and a 1, 0 should be a neutron. And number 9 says, on the Sun, the nuclei of 4 ordinary hydrogen atoms combine to form a helium isotope, helium-4. What type of particle is missing? So we have 411H, and it's going to a 42He. So what else must be here? Well, on the top, it's a 0. And on the bottom, it looks like it's a 2, but we don't have a subatomic particle that's a 2. So it must be 2 ones, so 2 positrons. Okay, so those are the 2 from the textbook. And now back to the multiple choice. So in the yesterday's, we ran out of time just before we got to 23 and 24, but they were being based on this reaction down here. Okay, and so it says the gamma photon makes a collision with an electron at rest. During the interaction, the momentum of the photon will, well, it should decrease, and the other guy should pick up some, right? It's just a collision, conservation of momentum. A certain radioactive isotope has a half-life of 2 days. 8 kilograms of the isotope is placed in a sealed container. How much will be left after 6 days? So after 3 half-lives, right? So it'll go to 4 to 2 to 1. So the correct answer should be number 1. Base your answer to 25 to 29 on the following information. The nuclear equation and nuclear equations. The nitrogen is bombarded with photons. The first reaction that occurs is of nitrogen 14 and the proton goes to oxygen 15 and something. The oxygen that's produced is radioactive and it decays into nitrogen 15. The first reaction is an example of induced transmutation, right? Not natural, because we're shooting something in. In the first reaction, what must X represent? Well, on the top, it has to be 15, so it'd be a 0. And on the bottom, it's also a 0. So the X must represent a gamma photon. In the second reaction, Y represents what? So in the second reaction, 15 on the top, 1 on, so 0, 1. And a 0, 1 should be a positron, choice 3. If 4 kilogram sample of that oxygen 15 decays for 0.4 of a second, the half-life was 0.1, so this is 4 half-lives. The mass that remains should be, so 2, 1, a half. It should be 0.25, I believe, if I did that right. I think I did. As the amount of oxygen 15 decreases, the half-life stays the same. The length of half-life does not change. Base your answers to 30 to 33 on this nuclear reaction. The first equation indicates that radioactive phosphorus is produced by bombarding aluminum-27 with alpha particles. In the first equation, particle X is, so do the math, on the top it's 31 on this side, so it has to be a 1. On the bottom it's 15, and it's 15, it has to be a 0, or 1, 0 is a neutron. In the second equation, particle Y is, so 30, 30, on the top it's a 0, on the bottom it's a 1, particle 1 should be a positron. The number of neutrons in the nucleus of aluminum-27 should be 14. Subtract the atomic number from the mass number. 34 to 37 are based on phosphorus 30 going to whatever this might be. In the equation, X represents what? It's a 0 positive 1. And so that should be, it must not be, yeah, there it is. I was going to say it's not a choice, positron. What is the value of A? So A must also be 30 because X is 0. So the value of A is 30. It's at the end of that sheet. Okay, next sheet. What is the value of Z? So we have a 15 over here, a positive 1, so this must be 14, which should be choice 1. Okay, the nucleus of phosphorus 30 has 30 protons, no, 15 nucleons, 15 neutrons, there it is. The function of the moderator in a nuclear reactor is to slow down the neutrons. An atom of 235 splits into two nearly equal parts. This is an example of fission. When a nucleus captures an electron, the atomic number of the nucleus, so this is the K capture, remember? It joins with a proton and it becomes a neutron, so one proton disappears, so the atomic number should decrease. In a nuclear reactor, control rods are used to speed up neutrons, no, absorb neutrons, that's it. During nuclear fusion, so the putting together of little atoms, energy is released as a result of combining light nuclei. When a neutron is emitted from a nucleus, sorry, I had to move the sheet, the atomic number decreases. No, it's not if it's a neutron. The atomic mass decreases, the atomic number does not change, both 2 and 3, because the atomic mass will go down and the atomic number will not change, because the mass number will change, but not the atomic number. When a beta particle is emitted from a nucleus, so a beta particle is a 0, -1, the atomic number decreases. No, the atomic number increases. Yes, the mass number decreases, the mass number increases. No, the mass number stays the same, but the atomic number increases. Because it picks up a proton, it loses a neutron. In the nuclear reaction, and that's beryllium, plus an alpha particle going to carbon 12. So on the top, if only I could see that. Whoops, sorry, I really can't see it now. I think it's beryllium 9. So that's 13 on the top, which means it must be a 1 on the bottom. A 1 on the top, and 6 and 6, 1, 0, so it should be a neutron. The nuclear reaction, uranium going to neptunium plus something, the X represents, must be a -1 on the bottom, so it must be an electron, or beta particle. In the nuclear reaction, man, I could only see helium plus nitrogen 14 going to oxygen plus something. So on the top, that's 18. So it has to be a 1. On the bottom, it's 9. So it has to be a 1. So Z must be a proton. When fission occurs, energy is liberated. The products weigh less than the original material. Energy mass is converted into energy. All of the above. It's all of the above. Fusion is produced by chain reaction, nuclear bombardment, intense heat, none of these. I'd probably go with none of these because you need intense heat, but you need more than that. So if you only have intense heat, fusion is not going to happen. You need intense heat, dense material, and a long period of time. And number 50, the process of fusion is accompanied by a loss in mass, gain in mass, a loss in mass, and that's what gets turned into the energy. Okay, and I think that's as far as I asked you to go the last set. I'll do the rest of them on the next set.